Hello everyone. This is the second video in a series on probabilities. In this video, we are going to look at simulations. I will start by explaining why we would want to do simulations. After that, I explain how you can do them on your calculator. And last but not least, I will end with an example of using simulations to figure out probabilities. But first of all, why would we do simulations? For that, let's first remind ourselves of what does probability mean. So, for instance, what does it mean that I have a 1/6 chance to throw 5 on this die? It does not mean that every 6 throws I get 1 5. What it does mean is that if I would throw it 1,000 times, approximately 1/6 of those throws would be 5. And we can reverse this. If I throw this die 1,000 times and I get 5 around 1/6 of the time, that must mean that the probability for throwing 5 is approximately 1/6. So the idea of doing experiments, doing something like this often, is to find out this probability if we maybe can't calculate it. And in some cases, we can do this in a more abstract way without actually throwing that die all the time, and then we get to simulations. So the idea of it is an easy way to do probability experiments so we can figure out a probability. Okay, but how do we do that with our calculator? Our calculator has a random number button. This is over here, so we first press Shift and then we press that button. So we get a random number and it gives us something like this. It gives us any random number between 0 and 1, and it depends a bit on your calculator, but probably you will get 3 digits, 3 numbers after the decimal point, in this case 263. And we're going to use that to do our simulations, because what we can do is translate any experiment to numbers. Sometimes that's easy. This die has 10 sides, so I can just say instead of throwing 1, I translate that to having a 1 in my number, up to, well, 10 is literally a 0 here, would also be the 0 in that number. But in some cases, a bit more difficult because we do have to be careful that the probability of whatever I'm looking for, in this case throwing 1 to 10, must be the same probability of getting the number on my die. So for instance, throwing a coin, 50-50 probability, I might divide that as one side is the odd numbers, the other side are the even numbers, or one side is 0 to 4 and the other side is 5 to 9. If I throw a regular die, I might even translate that even into just using the numbers 1 to 6, and if there's a 7 to 0, we just ignore that number. There's still, if we ignore 7 to 0 altogether, there's still a 1 in 6 chance, 1 in 6 probability to get a number from 1 to 6. So we're using those numbers, and then we generate a lot of random numbers, and that tells us what the results of our experiment would be. So one thing that is important, it is only possible if we know the probability of the parts of the experiment. I know that throwing a coin is a 50-50 probability, so that translates into numbers that are divided half and half. Okay, now this all sounds a little vague, so let's get an example of this. Suppose I want to know the probabilities of throwing 3 coins. I know the separate parts of this. I know one coin is 50-50 probability, and I could find the probabilities by just throwing 1, 2, 3 coins a lot of times. This case I got tails, heads, tails, and I could write that down. But that takes a lot of time. So instead what I'm going to do is I'm going to use that random number button a lot of times. And I'm going to translate it as heads is 0 to 4, tails is 5 to 9. And in this case, I used 40 numbers, and I got these numbers from my calculator, all randomly generated. Before we translate this into heads and tails, you might notice that in a few cases, the numbers are shorter. There's only 1 or 2 decimals. That's because after that are actually zeros, but those are not written down because your calculator doesn't find them necessary at the end. So we have to remind ourselves that they are there. So after I do that, I can translate all of these numbers into heads and tails, which looks like this. The first one, for instance, 0, 5, 1. 0 is heads, 5 is tails, 1 is heads again, so that's heads, tails, heads. And in this way, I have fairly quickly, only by pressing a button on my calculator 40 times and translating it, I have thrown 3 coins 40 times. That's 120 throws of coins. That would take a long time without my calculator. And from this, I can even put that into a diagram to have an idea of what happens. Now, 40 times as an actual experiment is not very much, and my data is not perfect. If it would be the perfect answer, we would actually have 5 on both of these and 15 on both of these. So it's a little bit off, but it gives us the general idea that 2 heads and 1 tails or 1 heads and 2 tails is a lot more likely and looks like the same probability. And 3 heads and 3 tails, again, also have the same probability and are much less likely. So that is the information that our simulation has given us. That's all I'm going to tell about simulations for now. I hope this gives you some idea of what simulations are, how you can use random numbers for them. And now it's time to try them out yourself.